Welcome to my projectbazaar.com. Now we discuss about the product LBP-based edge texture features for object recognition. Now we discuss the abstract for the process. This paper, the proposed two sets of novel edge texture feature discriminative robust local binary pattern, that is DRLBP, and ternary pattern, that is DRLTP, for object recognition by investigation the limitations of local binary pattern and local ternary pattern and robust local binary pattern, that is RLBP. The DRLBP are proposed as new features. They solve the problem of discrimination between the bright object against the dark background and vice versa inherent in LBP and LTP. DRLBP also resolves the problem of RLBP, whereby LBP codes and their complements in the same block are mapped to the same code. Furthermore, the proposed feature retains contrast information necessary for paper presentation of object contours that LBP, LTP and RLBP discards. Our proposed features are tested on 7 challenging datasets. Results demonstrate that the proposed feature outperforms the compared approaches on most datasets, and hence the proposed method is more efficient and reliable. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. In the dataset, they have contained the several number of images in the dataset. After getting the input image from the dataset, the pre-processing is undertaken. In the pre-processing step, we have to separate the RGB channels and then remove the noise from images in the pre-processing. After the pre-processing, the pre-processed image is undertaken for the illumination. The illumination is used to illuminate the background as well as the required object from the separated background. The color contrast is applied in this illumination. Then the edge detection is carried out. In the edge detection, we use the canny edge detection method for the edge detection. In this edge detection part, we have to extract the boundary of the image. That is, the boundary of the required object is extracted from the whole image and the other background are subtracted. Then the feature extraction is undertaken. In this feature extraction, we have implementing the two major algorithm for the feature extraction. The first one is SLBP for the feature extraction, and then the Gabor feature extraction is used to extract the feature from the image. After extracting the feature from the image, the classification is undertaken. In the classification, we have to consider the major two things. First one is the test feature and the second one is the train feature. The test feature is the feature which is extracted from the image or the query image. The train feature is the feature which is extracted from the whole dataset images. The classification result will be shown as the output. The classification result will be in the text form. The name of the recognized object is shown as the output, so that the test feature and train feature is classified. Now we discuss the initial running procedure for the process. At first, select the main.m file and right click in that file, then select the third option, run. Now the initial GUI window was opened. In that you can see the several buttons. These are known as the push button. Then this area is used for the axis. Then these tables are represented as an UI table. Now click the button load image. After clicking the button load image, the dataset folder is available. Then select the dataset folder. You can see the many images. These are the dataset images which is present in the dataset folder. Now select any one image from the dataset. The selected image is shown in the axis 1 with the title Query Image. The histogram of the corresponding image is shown in the figure 1 with the title Histogram of the input image. Now click the button Pre-process. After clicking the button Pre-process, the pre-processed image, that is the grayscale image, is shown in the figure, and also the boundary is extracted from the grayscale image. After extracting the boundary from the image, click the button Illumination Result. After clicking the button Illumination Result, the illuminated image is shown in the left side and the histogram of the corresponding illumination image is shown in the right side. These are known as subplot. Then click the button Train Database. After clicking the button Train Database, the train feature of the whole database is shown in the UI table 1. These are the results of the feature which is taken from the whole dataset, that is train image features. Then click the button Color Invariant Feature. After clicking the button Color Invariant Feature, the color feature of the image is shown in the UI table 2. Then click the button Color Histogram Feature. After clicking the button Color Histogram Feature, the histogram value of the image is shown in the UI table 3. These are the feature which is extracted by the color histogram. Then click the button as LBP. Now the LBP feature is applied for the image and the extracted LBP feature is shown in the UI table 4. Now click the button Classification. After clicking the button Classification, one new guy will be opened. In that you can see the two buttons. One thing is Classify and then Close. Now we have to click the button Classify. After clicking the button Classify, the category of the classification result is shown in the edit box 1 and the identified result is shown in the edit box 2. The classified category is classified and the identified one is the horse, which is the nothing but the object of our input image. Now click the button Enhancement. After clicking the button Enhancement, we have opened the one new guy window. In that you can see the two different categories such as LBP and Gaber. First extract the LBP feature from the image. Now extract the Gaber feature from the image. After extracting the Gaber feature from the image, the Gaber feature image is shown. Then click the button Next. After clicking the button Next, the feature extraction button is available. Click the button for the feature extraction and click the button for the train feature. This one is the test feature and this one is for the train feature. Now click the button Classify. Once again classify the image with one new algorithm, that is another algorithm. First of all I classify the image using the SVM and then now they classify the image using the KNN. Now click the button Classify. After clicking the button Classify, the classified target 1 is shown in the edit box 1 and the classified one is horse, which is shown in the edit box 2. Thank you.